Okay, so let's talk about how the universe began. So this is going to be called the Big Bang Theory, which is going to say that the universe began about 14 billion years ago. And initially, it was a very, very small entity, even smaller than the smallest fundamental particles that we can imagine today. It was also hotter than what we can possibly imagine today. So you may have heard of a thing called a supernova, which is when a star explodes. So the universe was even much, much hotter than that when it first formed. And then it started to expand. So space, which is up and down, sideways, in and out, so 3 dimension of space and 1 dimension of time, when you put that together, we call that space-time. So space and time began to expand at that moment in time and became eventually the universe that we see today. So we want to go through the steps involved in the formation of the universe, and they're summarized in this picture right here. And so remember, you can always make the picture bigger so that you can take a closer look at all the different things that are happening there. So how do we know that the Big Bang occurred? So when we look at galaxy clusters through our telescopes, we notice that the light given off by those galaxies is red shifted. So that means that the normal color of that galaxy has been, its wavelength has been shifted towards the red end of the spectrum. And so this is called a relativistic Doppler effect. And so we can calculate the speeds at which these galaxies are moving away from us by using this technique. So if we decide to take our clock and run it backwards, then that would mean that the galaxies would begin to come back together again. Then the second line of evidence is that the universe today has a temperature of 3 Kelvin. So you might be more familiar with degrees Celsius in the metric system, or degrees Fahrenheit in the English system of units. Well, the official metric unit for temperature is going to be called the Kelvin. And 0 Kelvin is the absolute coldest that anything could be. And at that point, at 0 Kelvin, molecules would actually stop moving because they would not have any energy at that temperature. So this corresponds to something like negative 273 degrees Celsius. But the point is that in outer space, you might expect it to be absolute zero, but it's not. It's 3 Kelvin, and the reason for that is energy from stars. Starlight makes outer space a little bit hotter, and then also the energy that's left over from the Big Bang. So we said that the universe began incredibly hot and incredibly dense. But then, as it expanded, that energy was spread out over a larger and larger volume. So that means that the overall temperature of the universe decreased. So now we know that based on these galaxies that are moving away from us today, that means that in the past, as we go back to 14 billion years ago, the galaxies were getting closer together, and so that must mean that the temperature was increasing. Okay, then the third line of evidence, we glean this from high energy physics, in which we take particles and we slam them into each other at very high speeds. So at higher and higher temperatures, the kinds of particles that you can create get smaller and more fundamental. And so that's why we think that the universe initially was very, very hot, very, very small, and composed of elementary particles. All right, let's take a break, and when we come back, we're going to talk about what is matter composed of.